Hi there, this is Sharmin. Hi there, this is Sharmin here. So this lesson will help you brush up on exponents and fractional exponents. Also, you will refresher on rules and scientific notation. So let's get started.
So as you can see, here is a 2 to the power 5. Here the 2 is a base and 5 is the exponent. And the whole thing, 2 to the power 5, is called a power. Alright, so now we'll start with the basic rules. So here is the basic rules, that is raising to the first power. So if you say 6 to the power 1, here is a 6. That means for any non-zero number, a to the power 1, so that means it's the a. And raising the zero power, so that is the 1. And negative exponent, that is the non-zero number. So you can see 27. So here is the x equal to 3. So that means x is a 3 times. And here is multiplying powers with the same base and raising a power to a power and another raising product to a power. Roots. So what do you mean by roots? So the opposite operation of raising number to a power is to take its root. Square root are the root that which we are most familiar. Taking the square root is especially essentially removing the square from the number. So 6 squared, that means 6 is at 6 times, that is 36. So technically 36 square can also be minus 6, or you can say minus 6 square also equal 36. To find roots other than the square root, follow the same process. Without a calculator, you can really only find perfect roots. Alright, fractional powers. Finding fractional powers are like finding roots. Fractional powers require a bit of logical thinking, but for our purposes, we can examine some problems that only require some brain power. So, briefly, here is the theory behind fractional powers. Let's look at it here. You can see that is 6, and this is the half equals to x. So half and plus half, so it will be whole number. So yeah, now go back to the replace 6 half with x. So that makes x equal to 4, which means the x that is a half equal to 4. That is the same as the square root of 16. All right. So if the numerator is a number other than 1, it tells you how many of the root number you need. If we raise 27 to power, we still find the cube root, which is 3. But we need is it twice multiply 3 the 3 times, and you get 9. Scientific notation is especially useful for expressing very large numbers, things, so very small numbers for microbiology. So numbers written in scientific notation are exposed of two parts. So the first part is a number between 1 and 10. It doesn't have to be whole number. Many are decimal numbers. So there can only be one digit to the left to the decimal. So the largest number is really 9.999, not 10. The second power is not raised to a power which can be negative or positive. So two parts are multiplied together so that they look like this example. So convert from scientific notation to standard form. Alright, so to write a number given in scientific notation as a number in standard form, you move the decimal point. The basic number of notation do not change. So the decimal moves and you may need some placeholder zeros. So the number of places the decimal moves is equal to the exponent. For a positive exponent, move the decimal to the right, you are making a big number. So for a mm, negative exponent, move the decimal to the left, you are making a small number. So that means here is an example, it makes sense a little bit. So move the decimal 5 places to the right and filling in the 3 extra places with zeros, and move to the decimal 3 places to the left and filling the 2 extra places with zeros. So now it's your turn to practice. So convert standard form to scientific notation. That means to write a number given in standard form as a number in scientific notation, there are 2 steps. First, write the decimal number. Remember, you can only have one place to the left to the of the decimal. You can have as many places to the right as necessary and drop any placeholder zeros. Here is the example. If you see here, that is the second. Raise the 10 to the correct power to determine the power. Count how many places you needed to move the decimal to the make your decimal number. The exponent will be positive if the standard form was a big number, that is the greater than 1. The exponent is negative if the standard form of the number is between 0 and 1. So here you see the decimal has to move 5 places, and another number you see, this is the decimal has to move 4 places. Alright, here is a question. Write the following expression with positive exponent and simplify the expression. Alright, this is the practice. You can do it. Applying exponent rules, here is some practice you can do. You can hang on your and practice. All right.
So guys, I hope that's all for today. Thank you for watching and see you soon with another new video. Keep watching, keep practicing, and good luck your test. Thank you so much guys.